In this video, we're talking about types of matter. So the objective is to differentiate between elements, compounds, and mixtures and identify the diatomic elements. So first, what is matter? And matter is anything that has a mass, so it has a number of particles that we can draw out, and takes up space, the volume. Some people might memorize this quicker as something that you can find its density. What isn't matter? So things like light or heat or sound, energy type things won't be able to be massed or find the volume for, so we're not considering them matter. There must be something else, energy. So there are many ways to classify matter like solid, liquid, gas, but one of the classification is if it can be separated physically or not. If it can be physically separated, it is called a mixture. I can separate those components out by maybe filtering it, right, or picking them apart. The second question in that mixture is the composition uniform? Meaning that when I look at it, does it all look the same, or do you see the different parts? If it all looks the same, it's called a homogeneous mixture, which we'll come to again near the later in the unit, also known as solution. It looks all the same throughout, like non-purified water, right, or milk. And if the composition is not uniform, it's called heterogeneous mixture. So I can see the pieces, like the chocolate chips in a cookie. Going back up to the top, if it can't be physically separated, it's a pure substance. It's clean, it's the same everywhere you go. There are actually two types of pure substances. If it can be physically chemically decomposed, meaning I can burn it or react it with energy or something, and it turns out to have two different components, that's a compound. And if it can't be chemically decomposed, it's called an element. That means it's a simplified state, elemental. So of the pure substances and elements that are elements and compounds, they have to be the same particle over and over and over again. They have to be the same composition throughout. So you can't have a different colored particle in there because that would be a mixture of those colors. The type of substances we have are elements where they can't be broken down. They're as simple as possible and they're made up of atoms. So the element symbols will either have just one letter capitalized, like the nitrogen is the capital N or hydrogen is capital H. Or if it has a second letter, that's always a lowercase letter. So like PB is big P but little b. So that's how you can tell a new element started with a new capital. And they all look like this, one type of circle throughout. Most elements are monatomic, meaning that there is one atom. Just like if you had a monocle, it's like when you don't have bifocals or regular glasses, you have just the one glass over one eye, like, in the old days. That would be monocle, one. Or monocycle, like unicycle, right? This is monatomic, one atom. And so most elements are this way, where they're only by themselves. And so sodium would have one capital letter N, and then the A to represent sodium instead of nitrogen. And although you can see many of them in one spot, it just means they're grouped together the same thing over and over again. A diatomic, so we would draw it like this, right? A diatomic element, such as hydrogen, composed of two of the same types of atoms actually stuck or bonded together. So H2, meaning that every time you see an H, it's binded to another one. It's kind of like twins, and they're always together. There's actually a couple of them, so we're going to memorize them because there's only 7, and they're called Brinklehoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorines, letters spell out this acronym Brinklehoff. Another memorizing technique is if you want to color your reference table instead. It starts at number 7, and it makes a 7 on the table. 7, like it looks like a 7 shape. So NOFCLBRI, and it goes up to hydrogen. So it's called the 7-up rule if you want to memorize it that way. But I usually tend to say Brinklehoff in class. So these are the ones that are twins, and there's a lot less twins than there are all these other elements that are just ones, right? Just like the world, there's a lot less twins than there are single people, right? Compounds means there's 2 or more different atoms, so not twins, totally different, and they're chemically combined. They will have a fixed composition, so it doesn't change. So everywhere you go, if you get purified water, whether it's here, in another country like France, or if you find purified water on the moon, hint hint, then it's going to definitely be H2O. Always, not HO2, not H3O, it's always two H's for every O. And they can be broken apart into the elements. If you electrify water, it will break into H2s and O2 separate. At this point, you should be able to differentiate generally between elements, compounds, and mixtures and identify the diatomic elements.